Have you ever spent hours debugging a problem only to discover that you are looking in completely the wrong place? Yes, I think most engineers have experienced this. Sometimes we see an error and immediately start changing the code. We add logs, change the condition, restart the application, try another solution, and sometimes we get lucky. But debugging should not be about luck. Good debugging is a systematic process of finding evidence, reducing possibilities, and identifying the root cause. Hello everyone, welcome back to Anupam Tech Talk. This is episode number 22, and today we are going to talk about debugging a problem systematically. Okay, let's move ahead. First, understand the problem. The first step is simple. Understand what is actually going wrong. Do not immediately assume that the place where the error appears is the place where the problem originated. For example, imagine a mobile application crashes when a user opens the payment screen. We might immediately think the payment screen has a bug, but the actual problem could be an API returning unexpected data. It could be authentication issue, it could be configuration problem, or another component could be sending an invalid value. So before changing anything, ask what exactly is failing? When did it start? Who is affected? Can I reproduce this issue? And what should have happened instead? Getting a clear problem statement gives us the right starting point. Second, reproduce the problem. The second step is to reproduce the issue. Try to identify the exact sequence of actions that causes the problem. For example, open the application, log in, navigate to the payment screen, select an option, tap pay, and the application crashes. Now, we have something concrete to investigate. Also, ask whether the problem happens every time or only occasionally. A consistently reproducible problem gives us very different starting point from an intermittent issue. If if it happens only occasionally, we may need to look at things like timing, occurrences, network conditions, or specific data. Third, gather evidence. This is one of the most important steps. Collect evidence before making assumptions. Look at the logs, look at the stack traces, check APIs, requests and responses, check application state, check database values, check configurations, and when necessary, use debugger to understand what is happening step by step. For example, if an API call is failing, do not immediately change the API implementation. First, ask what request was sent, what response came back, what status code was returned, was the response different from what the application expected. The more evidence we collect, the smaller the problem space becomes. So instead of saying, I think this might be the problem, we can say, this evidence tells us where the problem is occurring. Point number 4, narrow down the root cause. Now we need to find where the actual problem is happening. Think about the system as a chain: user interface, business logic, API, backend, database. We can investigate each part of that chain. Is the UI sending correct information? Is the business logic processing it correctly? Is the API request correct? Is the backend returning the expected response? Is the database providing the correct information? So instead of saying something is broken, we want to reach this specific component is failing because of this specific condition. That is the difference between guessing and debugging. Point number 5, fix the root cause. Once we identify the problem, we need to fix the root cause, not just the symptom. For example, suppose an application crashes because a value is sometimes null. We could add a simple check, null check, that may prevent the crash, but we should also ask, why is the value null in the first place itself? Maybe the API contract is incorrect. Maybe the validation is missing. Maybe another component is not initializing the value properly. The immediate fix might prevent the crash, but understanding the underlying cause helps prevent the same problem from coming back. A good engineer does not just ask, how do I stop this error? They also ask, why did this happen? Point number 6, verify the solution. After making the change, do not simply say it works now. Reproduce the original problem again, confirm that it is actually fixed, then test related scenarios, try different inputs, try unexpected data, consider network failure, and think about whether the change could introduce another problem. A good debugging process ends with verification, not just a successful build. The engineering leadership perspective. So, if I had to summarize my debugging approach, I would remember these 6 steps. Understand the problem, reproduce it, gather evidence, narrow down the root cause, fix the root cause, and finally verify the solution. The biggest lesson is that debugging is not about changing the code quickly. It is about reducing uncertainty until you understand what is actually happening. And as engineers grow into leadership role, this becomes even more important for them. A technology leader does not need to personally fix every bug, but they should help teams develop a mindset of systematic problem solving. Because when a team stops guessing and starts using evidence, the quality of the technical decisions improves. So remember, do not debug with assumptions, debug with evidence. The next time you face a difficult problem, do not immediately start changing code. Take a pause, understand the problem, gather evidence, follow the flow, find the root cause, and then make the changes. Thank you for watching episode number 22 of Anupam Tech Talk. I hope this gives you practical framework that you can use next time you face a difficult debugging problem. If you found this useful, share your experience in the comment. What's the most challenging bug you have ever had to solve? I'll see you in the next episode. Keep learning, keep building, keep leading.